Welcome to the Pacesetter 910. Today we are going to read the real number, the part 3. In that we are going to study about the relation between LCM, SCF and given both number. Given the both the numbers, correct? The both numbers. What is the relation? The relation you should remember the LCM multiplied by the SCF. The product of the LCM and SCF will be equal to the product of A and B, where A and B are the given numbers. Correct? Given numbers are there. So this LCM. Suppose it's better we should go for the examples. If we go for the examples, it becomes the quite easy. We will take the one of the question. Now, what is the question number 1? If SCF, the SCF of the number the 24 and 28 is the 4. The SCF is a 4. Then find the LCM. Find the LCM. So what we'll do it? We'll go for the extender. The what is the relation? These are rules. What is these rules? We will write LCM into SCF is equal to A into the B. Correct? We have to find the LCM. So we will leave the LCM here. Remaining all we will take it to the after the is equal to. So the LCM will be equal to A into B by A into B by the SCF. Correct? This is the SCF. Is a SCF. SCF. And what are the values are given? The given values are there. What is given here? The number A is equal to they have given 24. The B they have given the 28 and the SCF they have given is equal to 4. The everything we will write it here. Then what happens? The A into the B is a 24 into the 20. So it becomes the 14. 2 1 ja 2 and 2 7 ja. When you multiply the 24 into the 7, how much you are going to get? You are going to get the 188. So the 188 become the answer. 7 for the 28 to 7 to the 14. Just a minute. 7 for the 7 to the 14 or 216. Sorry, it will be the 168. The 168 become the answer. Correct? So this is the value you can get it. The next example we will see. The next example is in the question number 2. The question number 2 we will see the LCM and SCF. The LCM and the SCF. LCM and SCF of the two numbers. The two numbers are 350 and 350 and 5 respectively. Correct? The respectively. Then if one number is if they have given the one number is 50, then find the other number. Correct? Other number. Find the other number. So first we'll see the given. What are the things are the given? Given is the numbers. The LCM and the SCF of the two numbers are 350 and 5 respectively. means the 350 is a LCM. The LCM is equal to 350. The SCF is equal to, they have given is equal to the 5, or the one number, that is A. A is equal to the 50. Then you have to find the B is equal to the what? Correct? So what you will write? You write the standard formula. What is that? LCM into the SCF is equal to A into the B. You have to find out the B. So leave it the B here. Rest all this you bring it this side. So formula becomes LCM into the SCF divided by the A is equal to the B. Put the value of that. The LCM is 350 multiplied by the 5 divided by the 50. So 0 0 cut gaya. The 5 1 ja 5, 5 7 ja 35. So the total, the next number we are getting is equal to 35. 35 is equal to the B. So the other number will be, other number, that is a B is equal to 35. That becomes the answer. Correct? So that is the way you can do it. You can find out the value of the, when out of the 3 4 if the one is not given. Correct? So there are, if you understand, 1 2 3 4, the unknown figures are there. Out of the 4, any 3 are given, the fourth can be found out the same way. The next we will see the irrational number. What is the irrational number? We are aware the irrational numbers are the number which is a non-terminating and the non-repeating. The examples are root 2, root 2, root 3, and the root 5, root 7, etc. These all are the irrational, the number, correct? Irrational number. They are the irrational number. They are non-terminating, non-terminating and non-repeating. You can say non-repeating or non-reoccurring. Correct? Non-reoccurring. Correct? That also you can see. So this is called the irrational number. The one of the theorem is here. The theorem. What is a theorem? This is a part of the theorem of the first you have understood. Correct? The first theorem you have gone through. This is a part of the first theorem. The first theorem of the fundamental theorem of the arithmetic. So this is a part of that. So you see, remember, if a P, if the P be a prime number, be a prime number, be a prime number, and A be a positive, be a positive, the integer, the positive integer. Correct? The BBS A be a positive integer. If the P divides, the P divides A, the P divides the A square, then P divides A square, then P will also divide A. Correct? If the P divides A square, the P will also divide the A. Correct? This is the part of that theorem. You should remember, while you have to prove the many questions, then you should do it. Now, after this theorem, we will see the next question we will take up. What is the question? The question will be like that. Prove root 2 is a root 2 is a root 2 is a irrational. Root 2 is a irrational. So it remains the question same, whether they are the root 2, root 3, root 5, root 7, the same way you should proceed. The first what you have to do, you have to assume the contradict, the opposite of the fact. What you will do it? Let us assume. Let us assume that root 2 is a rational number, correct? A rational number. If we have assumed that it is a rational number, then certainly it will follow the p by q or the a by 2 the ratio. Then what will happen? The root 2 will be equal to a by b. You can take the p by q also, there is no problem. So if you are taking a by b, then b must not be equal to the 0, and 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 b are co-prime number. Co-prime number. The co-prime number you might have forgot it, correct? If you have forgotten, you should remember the co-prime numbers are the number which divides only by 1. Any other number than the 1, it cannot be divided, correct? So this is the co-prime numbers. The next step, what we'll do? Next step, we will do the by cross multiplication. If we do the cross multiplication, then what will happen? Root 2, the b will be equal to the a. How we got it? By cross multiplication. By cross multiplication you got it. After doing the cross multiplication, you do the square both sides. So what you will squaring the root 2, the b square will be equal to the a square, correct? So this will become like this. So what we say, it become the 2b square will be equal to a square. So the b square will be equal to the a square by the 2, correct? The b square will be equal to the a square by the 2. Understood? The a square by 2, correct? So this becomes, this you can take it the equation number the 1, correct? And b square is equal to the a square by 2. The theorem just now you have gone through. Here you can see the a, the if you find that the a square is divisible by divisible by 2, then a will be a will be also divisible by the theorem, correct? As per the theorem, if a square is a divisible by, we can see na, a square is a divisible by 2, then a will be also divisible by the 2. So this a will be divisible by divisible by 2. It will be divisible by 2 by 2 as per the as per theorem which you have gone through, correct? As per the theorem, it will be divisible by 2. The same, the a, this you are going to write, a will be divisible by the 2. So you write a will be divisible by the 2. When you divide the a by the 2, if you divide the a by 2, you are getting the c. Let c be a integer. C be an integer. The c is also the integers. Again, we will do the by cross multiplication. So we do get that a is equal to the 2c. Am I right? 2c by cross multiplication. By cross multiplication. Correct? Cross multiplication. Then by squaring, what we get? By squaring the both side, what we get? We get the a square is equal to the 4c square, correct? So we get the equation number the 2. This is equation number 2. Put the value of put the value of a square from equation number 1 to the equation number 2. Okay. One more thing we can, okay, equation number the 2. What we get it? We get that the 2b square is equal to 4c square, correct? So the 2 and the 2 square, correct? So the b square by 2 will be equal to the c square. So again here it says that what it says, the if the b square is divisible by 2, then as per theorem as per theorem the b will be also divisible by 2, correct? Also will be divisible by the 2, we know it, but we have assumed that the a by b, this is the co-prime number. So what we will do it? So we have assumed that it is a co-prime number, and the co-prime number is there, then it should be divisible by the 1. But we find that the a and b are the divisible by the 2. So it contradicts our statement. It contradicts our statement. So what we will write? We will write that we find we find that a and the b are also divisible by 2 by 2, whereas whereas we had assumed that assumed that they are they are co-prime number. It means what does it say? It means our assumption wrong. Assumption was wrong, and therefore we can say the root 2 is a irrational number, correct? Irrational the number, correct? The irrational number. So that is the way we can prove it, correct? It can be this the way by which you can prove it for the root 2, root 3, root 5, root 7, etc. Correct? This is all the step to be followed. But any other question other than this is being asked, then we need not to follow the complete procedure. For example, I will give the question number 2. The other example we see. Question is the prove that the 3 plus 2 root 5. 3 plus the 2 root 5 is a irrational number. Is a irrational number. Correct? Is a 3 plus 2 root 5 is a irrational number. What we will do? The first, let us assume let us assume that 3 plus 2 root of 5 is a rational number, correct? A rational number which is a contradict, correct? Then what will happen? Then it will be 3 plus 2 root 5 will be equal to a by b, where b should not be equal to 0, and the a and b are co-prime number. The same way we will write co-prime the numbers, correct? Numbers, correct? Then you should find out. We know that root 5 is a irrational number. So we will try to segregate, take out of that. The 3 we will take it to the other side. So it becomes 2 root 5 is equal to a by b minus 3, correct? So how much becomes? Is becomes The b, that is a minus 3b, correct? A minus 3b. Now the root 5 will be equal to a minus 3b by the 2b. This you got it. Here you can see the root of 5. Root 5, you know that it is a irrational number, and this you find that it is a and b. The a and b are the integers, so their ratio will be the rational number. We know that we know that a and b are integers. Hence, the a minus 3b by 2b will be a rational number, which is equal to which is equal to root 5, root 5 root which is equal to root 5. We know that root 5 is an irrational number, correct? Irrational number. So it contradict our assumption, correct? It contradicts our assumption, or you can say that our assumption was wrong. तो करेक्ट क्या होगा? जस्ट आप करेक्शन करो, क्या हो जाएगा? 3 plus 2 root 5 is irrational number, correct? So it become the irrational number can be proved. This is the way you should understand. There can be the different number also. If you get something like that, suppose the question is given, the other question, if it is a suppose 1 by root 2, then also you take the a by b, correct? Do the cross multiplication, correct? Then what it becomes? You will find that root 2 a is equal to the b. So a is equal to so root 2 will be equal to b by a. The b by a will be the other question. Just I am helping you out. The b by a will be always a rational number because it is a ratio of the integers, and root 2 we know that it is a irrational number, so it contradicts our assumption, and that is the way different questions are going. Then half of the way you should take turn taking direction that root 2, root 3, root 5 are the irrational number. So, gentlemen, I have finished the real number. If you have any doubt, you are most welcome. You can put up the question to me. Certainly, I'll try to solve you out. Thank you very much. Please do like the channel. Please subscribe, share to your friends, and do not forget to pass the comment. Thank you.